We're going to go ahead and take a look at now what it looks like to compare two quantitative variables as it looks right there. And the way we do that is by first taking the values from the two variables and then analyzing it through a scatter plot. So this is what this first section is. So what we want to look for when we take data like this, and I'll show you an ArtistStat in a little bit how to do this, but for now I did this by hand, so you can see this is the old-fashioned way. Do it by hand. Take your values, and we're trying to see if there's an association, right? And if there is an association, or what we call correlation, between these two variables, right? We'll look to see in this case if there's a relationship between grams of fat in a sandwich and the number of calories. And we get a visual inspection by looking at a scatter plot, X and Y values, like from an algebra class. And we're curious about if there's direction or shape in the distribution, right, of the two variables. And at some point we care about how strong this relationship is or association. So something you could think about as you look at this set of data that's been plotted. That's not a point there. These are the ones here. What happens to the number of calories, the Y values, as we increase the fat grams? And I see there's some general trend, and that's what we call a trend line. In this case, not all data has a trend line, but we see a trend line going up. And I drew a line in there to kind of get you a sense that you could see it's kind of going. It's not a perfect line, but it looks pretty consistent that as fat grams go up, so do calories, right? And then what the powerful thing about a scatter plot and trend lines is that we can make predictions. So like something like if a sandwich has 14 grams of fat, can we estimate how many calories it would have? There's that where I have the 19 on 14. And you kind of go up to see somewhere in here, right, we would estimate. So somewhere in that 350 to 450 range, we would estimate, right, based off the trend. And so some terminology, right, to think about is we want to see if two variables are associated, right? If they are, then there's a relationship. The relationship does exist. And we know we can think of relationships of variables in our world. It's just in this case, we're looking at two quantitative variables. Okay, for example, males are associated with shorter hair, females associated with longer hair, potentially, right? This idea of associated. Now, correlation is another word that we throw out, and this is when we quantitatively, right, when the both variables are quantitative and then we describe the relationship numerically, we're talking about correlation. So when we use the word correlation, that means we've actually done some calculation to look at the relationship. And then the correlation, right, and we end up getting something later called the correlation coefficient. We will say that it's positive or negative depending upon the direction. So you could see some example down here. And some words we would use to describe this association, correlation, right? Correlation is when we actually do a calculation. Here you could see here there's a positive correlation. It's going up. As one variable increases, the other one also increases. A negative correlation here is when one variable is increasing, the other one's decreasing, then we have a negative correlation. Important to distinguish between those two things. Here I see a linear relationship, just like a trend line. Here it's like no correlation, there's no shape, it's kind of randomly scattered, no direction per se, so we would say no correlation, no association. Again, correlation is when we actually do some calculation with, then we use that term. So we use that term, we've done some calculations to compare two quantitative variables. And then we see a set of examples to end this section here, looking at different scatter plots and then the different types of relationships. Negative, linear, kind of strong, just kind of going down. This one's a little bit more scattered. We may say weak. It looks kind of positive, but it's not strong, right? Again, these are sometimes subjective in some way. We're going to have to come up with some like statistic, and we do. It's called the correlation coefficient to help us get the exact kind of strength, how strong it is. This one has some correlation, but it's non-linear if you think about it. See how it's curved? So that's a different relation. That's a more advanced topic. This is one here, and then with some outliers. So it's still strong, but then we have some interesting data points. And here, this is not as strong, moderate, but positive. So take a look and hopefully you can practice that on your homework. But again, this is our introduction to comparing two quantitative variables. Again, quantitative.